Hi everyone, this is Mrs. Ramirez. We're going to be looking at balancing chemical equations this week. I know we started last week, so we're going to continue looking at different types of equations so that we can get comfortable in balancing chemical reactions. The reason why we balance chemical reactions is to obey the law of conservation of matter, or the law of conservation of atoms, which states that we must have the same number of atoms before and after the reaction, or in other words, in the reactant side and on the product side as well. So as we start balancing reactions, we want to make sure that we understand that we must use these numbers called coefficients. And these numbers called coefficients are going to be placed in front of a molecule. I want to just review a couple of rules as we get started. We want to make sure that we understand we can only add coefficients. There's nothing else you're really messing with in the reaction. You can't, as it states here on the screen right now, you can't go ahead and break the formula apart and try to add numbers in the middle of a chemical formula. You can't go ahead and change the subscripts that are there already in the chemical formulas in the reaction. So as you look at rule number 1, only add coefficients. So I want to just translate that in, as you see here going over this example, that 2 box right here, let me go back, that 2 in front of the H2O is going to be a coefficient. And this is an example of where you would place that coefficient in front of the chemical formula. Once you add that coefficient, you're going to distribute that coefficient to everything behind it, which means you're going to distribute that to not only to the hydrogen, but also to the oxygen. And that means you're going to multiply that 2 by any subscript that you see in the chemical formula. So currently, before we do that, currently we have 2 molecules of water, but we want to identify how many atoms we have in those 2 molecules of water. So looking at and breaking it down, we are going to take that 2 and multiply it, distribute it to that hydrogen. Now there's a 2 next to the hydrogen, which means we're going to end up with 4 hydrogen atoms. And then we're going to do the same thing with oxygen. Now there is no subscript next to the oxygen, so there's basically 1 oxygen atom. If we distribute that 2 to that 1 oxygen atom, that equals 2 oxygen atoms. So for every 2 molecules of water, we are going to have 4 hydrogen atoms and 2 oxygen atoms. Okay? So the coefficients, as it states in rule number 2, do not go in the middle of a molecule. They go only in the front of the chemical formula, chemical compound, or the molecule. Okay? These are just examples, again, more rules, and stating that you cannot change these subscripts. The only thing we can do is add coefficients. Okay? So I'm going to move this over here. So let's take a look at some problems here that I've set up so we can kind of review. And we're going to use the tally method to balance the equations here. Okay, so what we have here is lithium reacting with oxygen gas. Remember, oxygen is one of those 7 diatomic that when they are by themselves, it's going to have a subscript 2. And they're going to produce lithium oxide. First thing we're going to do to try to balance the reaction here is list the elements that we have. Now you only list them once, obviously, because they appear on both sides of the arrow. So we have lithium, and now we have oxygen, and notice oxygen appears here, and it also appears on the product side. Now that we've listed the elements, we are going to count the number of atoms that we have for each element on both sides. And we're going to start with the reactant side. So right now, there's only 1 lithium atom. So we'll place it on this side representing the reactant side. And currently we have 2 oxygen atoms. Now let's take a look at the product side. We have currently 2 lithium atoms and we have 1 oxygen atom. So now notice that the numbers here don't match. There's 1, there's 2, and there's 1. So this is not balanced. So we're going to try to now add coefficients in front of these chemical formulas or element names so that we can go ahead and balance correctly. So let's start with the lithium. We'll place a 2 in front of the lithium here on the reactant side, which now increases this 1 to 2. Okay, now this lithium atom is balanced. So let's try to see if we can balance the oxygen atoms. Okay, so the only place we can add a 2 to balance the oxygen is in front of the chemical formula. You can't break this and try to put a 2 next to the oxygen. Okay, only goes in front of the chemical formula, which means we are going to distribute this 2 to everything in this chemical formula right here, this compound. So we have to distribute this 2 to the lithium, so which means that's going to end up as 4 lithium atoms. We're going to distribute this 2 to the oxygen as well, and now that's going to increase to 2 oxygen atoms. So notice what happens. We increase that oxygen number to 2, and now we've increased or doubled the number of lithium atoms to 4. And the reason why, because if you take this 2 and multiply it by that 2, that gives you 4. Oxygen, there's no number next to it, no subscript, so it's a 1. So 1 times that 2 gave us the 2 oxygen atoms we now have. Okay, so let's go back and look at our tally here. We have 2 and 2 oxygen atoms are balanced. Now our lithiums are unbalanced again. So we have to make sure it's balanced by changing now this 2 to 4. And now that we have 4 lithium atoms, we'll change that, okay, number here. And now we have 4, 4, 2, and 2. Okay, this is kind of the starting point doing this tally in the middle here, because once you practice and you get more comfortable, there's no need for you to list the elements and write these numbers down. You can kind of just mentally do it as you visualize the chemical equation here. So notice we didn't do anything to this oxygen. You can leave it blank or you can put a 1. Okay, means the same thing, but don't put a 0 because then that really is not the correct number to put as a coefficient. You can put a number 1 or higher. Okay, now let's take a look at this next problem, which includes some polyatomic ions. Okay, and we're going to do the same thing as we did in the previous problem. We're going to first list the elements we have. And we'll start with iron. Okay, and next thing we're going to do, we're not going to break this down into sulfur, oxygen. We're going to treat this polyatomic ion as one thing. Okay, so we're going to keep it as SO4. We're not going to break it down. Okay, because we know SO4 or sulfate ion has a charge and we're going to treat it as one unit. Okay, so helpful tip, do not separate polyatomic ions. Okay, moving on along, next thing we're going to list is sodium. Okay, and then we notice that the sodium bonded with this phosphate ion. Okay, which phosphate ion has a 3 negative charge. So this phosphate ion, okay, that bonded with the sodium, we're going to treat it as one thing, one unit. So we're going to leave it as PO4. And they use parentheses to just make sure that you isolate it as one thing, not necessarily needed to add those parentheses. Okay, and you don't have to write these again because we only want to list the elements once. Okay, so in that way we can just add these numbers on the left and on the right of the list. Okay, so the left side again represents the reactant side, and we're going to identify how many atoms of these we have. So we have 2 iron currently, and next one we're going to notice that there's a 3 outside of the parentheses. So that tells us that there's 3 sulfate ions there. Now we move on to sodium. There's a 3, so there's 3 3 sodiums, excuse me. And then we have no parentheses, no number outside of parentheses, so that tells us there's only 1 phosphate. Okay, on the right side, the product side, we currently have 1 iron. There's no subscript there. We have no parentheses or number outside of the parentheses, so that means we're going to have 1 phosphate. But next on the list is sulfate ion. Here we go. There's again no parentheses, okay, which means we're going to have 1 SO4, okay, or sulfate ion there. And then we have sodium, there's 2, and then there's 1 PO4, okay. So we want to kind of look through here, and we notice that this reaction is not balanced because these numbers do not match. And we want to make sure we do. So the first thing we're going to do is add a 2 in front of the Fe, okay, PO4, the iron 3 phosphate. And again, you can only put these coefficients in front of the chemical formulas. And the moment you do that, you want to make sure you distribute to everything behind it. So now we have 2 irons. We're going to change that to 2, okay? And we also have to add, we want to make sure that we distribute that 2 to the PO4, okay? Now, distribute that. We're going to go ahead and make sure that PO4 is treated as a unit, 1 unit. That means we distribute, and that gives us 2 phosphates. Okay, so let's go ahead and change that. So, alrighty. Next thing we're going to do is add a 3 because we noticed that we have 3 sodiums on the left and 2 sodiums on the right. Now, be careful because we already have a subscript 2 here, which means we have to distribute. Okay, that 3 distributes to everything behind it, which means that's going to increase to 6. 3 times 2 gives us 6. Okay, and you're not going to multiply. A lot of times this is where students get confused. Just because you see a 4 there, do you multiply that 3 by the 4? You don't, because this is sulfate. It's 1 unit. Okay, so this is going to be 3 sulfates, and then that sodium is going to be 6 atoms of sodium. Okay, seems like the irons are balanced. Seems like the sulfates are balanced. Okay, we now have to balance the sodiums and the PO4. Okay, so we're going to go to the right side here, or the left side, excuse me. So we're going to add a 2. Okay, we're going to go ahead and put a 2, and that distributes to everything behind it. So again, 2 times 3 will give us 6. Okay, so we're going to change that to 6 sodiums. And now that 2 distribute to the PO4, okay? It's not in parentheses. So that means we currently have 1 phosphate. Distributing that 2 increases it to 2 phosphates, okay? All right, so I think that we're going to now double check. There's 2 and 2, 3 and 3, 6 and 6, 2 and 2. Okay, everything's balanced. The only one we didn't add a coefficient was for this first one, which means you can just leave it blank or you can add a 1. Okay, it's balanced. All right, let's take a look at this next example. We're going to list again aluminum, we have sulfur. Let's identify the number of atoms of each one on both sides. On the reactant side, left side, we have 1 atom of aluminum, 1 atom of sulfur. On the product side, 2 aluminums and 3 sulfurs. Okay, so it's not balanced, so we have to balance it. Let's start with putting a 2 in front of the aluminum. That increases our reactant aluminum to 2. And now let's put a 3 in front of the sulfur on the reactant side. Okay, that changes to 3. And now it seems like everything is balanced. So again, we didn't have to touch this one. So we can just leave it as, balanced, or a 1, excuse me. Okay. So like it says here, if the numbers match on either side, okay, we want it to match on both sides, then it's balanced. There's no need to add number here. It's already balanced. Okay, you can leave it as a 1. Okay. All right, we're going to just review a few more. I have a few more problems for those of you that still Can't get it. And I think the ones that become a little harder are the ones where you have polyatomic ions, being able to identify those. So we're going to go ahead and just take a look at a few I have here. So we have this first problem. Okay, and I'm going to move myself up there. I've gone ahead and identified, listed the elements here. So we have sodium, okay? Again, we have phosphate, PO4, and there's only one of them because notice here, okay, we have, there's no parentheses, so we're going to treat it as one, okay? Let me see here if I can undo that one. I'm going to go ahead and circle it here, okay? And now we have potassium, okay? And we have hydroxide, okay? There's no parentheses, so it's treated as just one here. I'm going to circle my polyatomic ions here. Okay, now let's go ahead and identify the number of elements, okay, or the number of the number of atoms for each element that we have. Let's start on the reactant side. We have 3 currently. We have 1 phosphate, 1 potassium, 1 hydroxide. On the product side, we have 1 sodium, we have 1 phosphate, we have 3 potassiums, and then we have 1 hydroxide. All right, so I'm going to go with the ones that are not balanced. Notice here the sodium, we have 3 and 1. So I'm going to balance that one first. So we want to make sure that we start with the lowest one, okay? Want to go with the lowest, we're going to put a 3 there, okay? So as we put a 3 there, this 3 distributes to everything behind it. Okay, so now we don't have 1 sodium. Adding that coefficient, we distribute it. That's 3 sodiums, and that 3 is distributed to the hydroxide, which means now we've increased to 3 hydroxides. Okay, now it seems that our sodiums are balanced. Okay, our phosphates are balanced. Let's go to the potassium. Okay, notice that potassium has 1 and it has 3. So we're going to try to balance the potassium on the reactant side since it's our lowest integer here. Okay, can't change that higher. Want to make sure we start with the lower one here. So we go and put a 3. Okay, so again, this 3 will distribute to everything behind it. So that increases 3 phosphate, and that increases that polyatomic ion now is going to turn to 3 phosphates. Okay, so let's double check. We have 3 sodiums on both sides. We have 1 phosphate on both sides, 3 potassiums on both sides, and now 3 hydroxides on both sides. Now you can leave these blank, these ones right here, or you can put a 1. I like to just leave them blank. Okay, it doesn't matter. It's not going to change anything if you leave it blank. It's basically saying the same thing as you adding a 1. Okay, next one. We have magnesium with fluorine, magnesium fluoride. So we've listed all of the elements. We have magnesium, fluorine, lithium, and then again we have a polyatomic ion that we're going to just circle it. Okay, it's 1 unit. Okay, so let's identify the number of atoms that we have of each type. So let me go ahead and change that to a different color. And here we go. We have 1 magnesium. We have 2 fluorines. We have 2 lithiums and then 1 carbonate. Okay, let's go to the product side. We have 1 magnesium. We have, we have 1 carbonate here. So we'll put the 1 down there. 1 lithium and 1 fluorine. Okay. Seems like our magnesiums are balanced, so we're going to leave those alone and move on to the next one, 2 and 1. Let's go to the fluorine. Okay, now fluorine on the product side is right over here. Okay, so we're going to put a 2 to balance that one with the reactant side. So the moment we put a 2, and this is the only place we can place those coefficients, that's going to distribute. So now we have 2 lithiums, okay, and now we have 2 fluorines, okay. Now it seems like If we look at the following: fluorines are balanced, lithiums are balanced, and the carbonates are balanced as well. So the only number we had to add was on that last product, chemical formula, lithium fluoride. So the other ones can be left as is, or we can go ahead and just put a 1. It's up to you. Next problem. All right, let's identify the elements here. We have phosphorus, and then we have oxygen. Now let's identify the number of atoms for each one. Okay, we have 4 on this side. We have 2 on this side, the reactant side. Now let's go to the product side. We have 2 P's and we have 3 O's, or oxygens. Okay, now let's try to balance the product side. Okay, so we're going to go ahead and increase this 2. Try to put a 4, make them 4. So we have to add a 2. You're not going to put a 4 because notice there's all there, and you're going to end up distributing this 2, everything behind it. So if we distribute this 2, you're going to multiply that subscript by the coefficient. So that increases the number of P's to 4. Okay. Same thing with the oxygen. 2 times that 3 is going to give us 6. Okay. All right. Seems like the P's are balanced. Now we have to look at our oxygen. So this one is 6. This one's 2. Let's add 3 here. Okay. 3 times 2 is going to give us 6 oxygens. Okay. Now it seems like everything is balanced. 6, 6, 4, 4. We'll just leave that one blank. Okay, gives us the same. Okay, leaving it blank, or you can add a 1. It's up to you. Okay, let's take a look at this next one. We have, again, some polyatomic ions. So let's list how many we've listed, actually. Rubidium, we have the nitrate, beryllium, and the fluorine on both sides. Now let's count. We have 1 rubidium. We have 1 nitrate, we have 1 beryllium, and we have 2 fluorines. We have how many rubidiums? We have 1. Nitrates, notice there is a parenthesis on this one, and there is a that's going to tell you how many polyatomic ions of that specific kind you have. So we have 2. And then we have 1 beryllium. This 2 is only identifying what's inside the parentheses, nothing else. So there's only 1 beryllium, and then there's 1 fluorine. All right, let me take a look at my rubidiums. They're balanced, and our nitrates are not balanced, and our fluorines are not balanced. Okay, so we're going to try to balance these. So let's start with the nitrates. Okay, so let's try to balance the nitrates first. So we'll put a 2 in front of the rubidium nitrate. Okay, so that is going to distribute. So it not only affects now the nitrates, but also the rubidium. So now we're going to change that 1 to 2. And now we have 2 nitrates. Okay, seems that our now rubidiums are unbalanced. We have 2 on the reactant side and 1 on the product side. Okay, so let's try to balance our rubidiums here. So let's go now back to the product side, and we're going to put a 2 right for the rubidium fluoride. So again, we distribute to everything behind that coefficient, and now we change that 1 to 2, and now that's going to change our fluorines to 2. Okay. All right, now we have rubidiums are balanced, nitrates are balanced, the berylliums are balanced, and fluorines are balanced. Okay, so that one's done. And again, you don't have to add 1s, just leave it as it is. It means the same thing for the ones that we did not add a coefficient to. Okay, all right, so want to make it seem like it's a 0. All right, we are coming close. We have 2 more examples. Here we have silver, nitrate, and copper. We have silver nitrate that's reacting with copper to produce copper 2 nitrate, and then silver metal there. Okay, now We've listed the elements. We have silver, nitrate, and copper. Okay, we list them in that order, and then we're going to identify the number of atoms for each one. So we have one silver on the reactant side, one nitrate, one copper. Let's go to the product side. We have one silver, and let's take a nitrate is a polyatomic ion again. And notice there's parentheses. So in that subscript, outside of that parentheses will tell us how many of that particular polyatomic ion we have. So there's two nitrates and then one copper. This 2 doesn't mean there's 2 coppers. That 2 means there's 2 nitrates. Okay, so there's only 1 copper for that particular chemical formula. All right, silvers are balanced, nitrates are not, coppers are balanced. So let's go to the nitrates. So we have to balance we're going to change our 1 to 2. So we're going to put 2 on the reactant side. So we have now increased. Again, that 2 changes everything behind it. So now this is going to change our silvers to 2. And now we have 2 nitrates. Okay. All right. We've unbalanced our silver atoms. So now we're going to go to the product side and we're going to balance it by adding a 2 in front of it. That changes to 2. So it seems our silvers are balanced, nitrates are balanced, and our copper metals are balanced there. Okay, last one here. We have carbon tetrafluoride reacting with bromine gas to produce carbon tetrabromide and fluorine gas here. Okay, so we have carbon, fluorine, and bromine. Okay, we're going to list the elements that are in the reaction, and now we're going to count the number of atoms of each element that is on each side of the arrow. So we'll start with the reactant side. There's 1 carbon, there's 4 fluorines, and there's 2 bromines. Let's go to the product side. 1 carbon, we have 4 bromines, and then we have 2 fluorines here. Okay, carbons are balanced, fluorines are not, bromines are not. So let's start with the fluorine. So we have 4 and 2, so we want to increase this 2 to 4, and we're going to put a 2 there because there's already a 2 subscript there. That's going to multiply 2 and 2 will give us the 4 that we need. Okay, now bromine, that's going to be 2 and 4. We want to increase that 2 to 4. So we want to, again, add a 2 here. That's going to distribute. 2 and 2 will give us that 4 that we want. So carbons are balanced, fluorines are balanced, and the bromines are balanced. So now that everything is balanced, we're going to go ahead and just leave it as is. These, again, you put a 1 or you don't have to put a 1. It's not going to make a difference. Okay, I think we are done. I hope this tutorial video helps you. I will be adding this video in Edpuzzle and asking a few questions, and hopefully this will help you continue to practice and understanding how to balance equations. All right, have a great one.